Alright, hello and welcome to the second example in section 13.2. We're just looking at another example, looking at a recursive routine and just looking at finding the terms in the sequence, classified as if arithmetic or geometric, and then looking for the explicit definition. So starting off, we've got t sub 1 equals 20, t sub n equals t sub n minus 1 minus 3. So let's start by finding our second term in the sequence. So plugging into our recursive routine, where basically n is now 2. So we get 2 minus 1, and then minus 3, simplifying. We get that t sub 1 minus 3. And so again, kind of like the last example, t sub 1 is our previous term. We already know that. We know it's 20. So plugging that in, we'll get that 20 minus 3 is equal to 17. And so that is t sub 2. So continuing on, finding a few more terms in our sequence. If we look at t sub 3, we'll plug in n equals 3. So we get 3 minus 1 minus 3. So leaving us at t sub 2 minus 3. Now again, it's building off of the previous term. So the idea that t sub 2 is 17. So we're really doing 17 minus 3, which gives us a value of 14. So again, if you start noticing patterns in your sequence, please feel free to use that pattern to continue your sequence, because sometimes the notation is a little bit bulky. So feel free to notice here that we are just having a difference of 3. So if we continue that difference of 3 to find our next two terms, we'll get that 14 minus 3 is 11, and then 11 minus 3 is 8. So they would be the first, or the second, third, fourth, and fifth term of our sequence. So once we have that information, we can see that we've got this constant difference, so it is going to give us an arithmetic sequence. So based on that, we're then looking for the explicit definition, which again goes back to section 13.1. So looking at 2 sub n equals t sub 1 plus n minus 1 times d. So for our arithmetic sequence, what we need is a few things. Our d value is going to be negative 3, since that's our difference, and then our t sub 1 value is 20. So plugging that in, we'll get that t sub n equals t sub 1, which is 20, plus n minus 1 times our difference of negative 3. Now typically it's a little bulky the way it is, so we'll just clean that up, distribute the negative 3 through the parentheses, get a negative 3n plus a 3, combine our like terms of 20 and 3 to get that 23 minus 3n is equal to t sub n. And so that right there is going to be our explicit definition. So if they're ever looking for that versus the recursive routine, that's what it is. It's using that formula. Alright, so this is our second example, looking at an arithmetic sequence. We have just one more to look at with recursive routines. So I'll see you in the next video, or talk to you at least in the next video. Thanks for listening.